Hello again guys, and welcome back to science class. Last class we talked about pressure and how to calculate pressure. Today we will revise what pressure is and how to calculate it, and also move on to talking about pressure in gases and liquids. Okay, here we go. Remember, the formula to calculate pressure is pressure equals force divided by area, or P equals F over A. The unit of pressure is the Pascal. This comes from 1 Pascal is 1 Newton per meter squared. Why? Pressure equals force over area. The unit of force is a Newton. The unit of area is meters squared. So pressure is newtons per meter squared. Okay, on to today's topic. Gases and liquids also have pressure. You don't believe me? Think about these. A balloon stays inflated or gets bigger because of internal pressure from gas. You put this pressure in there by blowing up the balloon. The fireman on the right is using high pressure water in his fire hose to shoot water at a fire. So you can see gas can be under pressure and water can be under pressure. Pressure increases as we go down in the ocean. At the surface, there is a pressure of 1 atmosphere. This is a balloon at the surface. It is at 100% gas volume. As we go down, the pressure increases. This pressure causes the balloon to get smaller. Down at 50 meters, the balloon is only 17% the size at the surface. Pressure increases as we go down in the ocean. Here we can see a simple experiment which shows this. Pressure causes water to shoot out further at the bottom of the bottle. At the top, we can see it shoots out not very far because the pressure is low. But at the bottom, the pressure, high pressure, causes the water to shoot out very far. The atmosphere puts pressure on you all the time. We live at the bottom of an ocean of air. All this air presses down on us all the time. Air gets less dense as you climb a mountain. So what do you think will happen to the pressure? Well, if air is less dense, there will be less pressure on you on top of the mountain. Atmospheric pressure is the pressure of air or the atmosphere on you. To explain the pressure of the atmosphere, we can use this diagram. At sea level, The pressure is 101,000 pascals, or 101 kilopascals. If we go up to the top of Mount Everest, the pressure decreases to 31,000 pascals. We can keep going up until we reach the edge of the atmosphere. At the edge of the atmosphere, the pressure is 0 pascals, and then you are in space. Why does air and liquids have pressure? The answer is to do with particles. Here we see a box full of gas or liquid particles. Particles of gas move around in the box. The particles bounce off the walls all the time inside the box. Each particle gives a tiny force to the edge of the box. But all the particles together have a big force on the area of the box. Remember, force on area is pressure. So, the pressure in a gas or a liquid comes from the particles in that gas or liquid moving around. Alright guys, that's the last thing for today. I'm going to send you some questions to do for homework. Please do them. And I will talk to you next time. Alright, bye-bye.